So is every letter. So everything is geometry. Of course, Gargot has been described by the European Mathematical Society as being a geometric dynamic, a geometro dynamic study of or form of unified field theory. Unified field theory. Except it's not a theory, it's a theorem. Okay? But that's a classification by the European Mathematical Society that it's a geometrodynamic, meaning it is a geometry way to view the universe, which is kind of on the surface look like it's different from the kinetic way of viewing the universe or the quantum approach of dealing with the universe. Okay? But there is a relationship. Okay? There is a relationship. So, and as you can see, part of the relationship being demonstrated by Gargot explaining the origin of this. Yeah, well, you were talking about geometry. I'm defining geometry, and I'm giving examples, okay, as a way of defining geometry. Geometry is the science of shapes, okay? It turned out that it is, according to Gargot, that's it. It's about shapes, okay? And that's what all mathematics is. And I'll give you just a little flavor if I can, okay? But I was also saying that the European Mathematical Society have classified Gargot as a geometrodynamic form of a unified field theory, okay? Or a geometrodynamic description of the universe. That's the classification of Gargot by the European Mathematical Society. Okay? And that, of course, is going to be explained when I get to the core of Gargot in terms of what is Gargot as such. Okay? What I've told you so far is what has Gargot done, okay? Before you get to know, what really Gargot is. Okay, I hope people are not thinking about, well, you're going around. No, we're not going around. You see what the theorem does first. Okay? Then you'll see, in effect, what it is in reality. But we're trying to get there, and we're trying to bring along with us the ingredients that basically summarize Gargot, that made Gargot possible. Okay? It's ancient African origins. Okay? We got to bring that along so we don't, because that forms a basis of comparison for us in terms of, existing theories that you need to verify if you are coming up with a new theory, which in this case we call a theorem. So geometry is very, very important. It came out as a result of an attempt by ancient Africans to glorify the Almighty God for the gift of chemistry. Okay? They wanted to build an edifice. The subject geometry was developed as we know it. The geometry has always been there, shapes and so, because human itself is a shape, it's a geometric shape. Okay? Yes, you have, all these nice curves and all that. That's geometric shape, a curve. Okay? Studying a curve is studying geometry. Now, to see why there is nothing beside geometry to mathematics, you've been told about.
Would I be correct to say that geometry is a system of measuring, defining, determining the boundaries?
Well, it's the study of shapes, okay? Study of shapes. That's basically what geometry is. Shapes.
Study of shapes.
Yes, that's basically what it is. Okay? It's simple language. You can talk all kinds of other
well,
things.
The reason why I said numbers and tried to put that into it is because when we think of measurement,
yes,
we think of numbers.
Well, yeah, but measurement is shape. You're talking about shape in measurement. A line is a shape, okay? Yeah, you know, the reason you're making a measurement is because there's some kind of shape there.
Right.
So the study of shape, the measuring is part of the study itself.
Right.
Okay, so, but this is what happens. Your arithmetic, okay, evolved from geometry, from this line here, which is, this is a geometric entity. A line is a geometric entity. Okay? That's a shape. A line is a shape.
Okay.
Arithmetic came out of this. The entire arithmetic is on this line here. If you like, you can have a reference point you call 0. And the rest goes to 1. That's right. Infinity. And then if you go back this way, because if you have monies, you can owe money as well. So when you owe money, of course, you have a minus. Okay, it's a matter of convenience. Okay, right to minus infinity. Okay, this line summarizes the entire arithmetic. Arithmetic. Okay.
But that's just linear counting.
Oh no. Arithmetic. Arithmetic is numbers. That's all. That's all. You can put it into some kind of language to ask a question. Ultimately, you're going to get numbers. That's arithmetic.
No matter
what else are you going to do? You add two numbers. You subtract, right? What else are you going to do? Arithmetic. You do accounting. The end figure is number. It's all on this line. This is arithmetic here, this line here. Okay? That's all. There's nothing else.
Well, I was just trying to associate that with measuring.
Oh, yeah, no. See, the measurement part of that is taking this line here and cutting this portion here and say, well, this represents 1 unit. That's measurement. That's your measurement. Okay? So you call this here, you drew this here, and you say, and it's arbitrary. You know, they use human foot to talk about foot, a foot, a measurement, an inch, some other characteristics. All those are arbitrary. There's nothing that was sent directly from God to be that and only that way. Okay? So, but technically you can cut this line into portions, all kinds of portions. Okay? They could represent real numbers, you know, integers, whole numbers, you know, rational numbers, and all kinds of numbers are represented there. Okay? All right. So therefore, so that's arithmetic. When you begin operating with arithmetic and you want to generalize results, okay, for example, 1 plus 2 is equal to 3. That's still on this line here. In other words, when you add two integers, okay, you get another integer. Okay? Right. So instead of saying 1 plus 2 is equal to 3, which is an integer, and then you say, okay, 4 plus 5 is also another integer called 9. Okay? All right? Okay? And, you know, instead of doing that, you put it in a symbolic form. A plus B is equal to C. Provided that A and B and C are integers, this sums up all similar operations that you're doing here. Yes, but you only have one line instead of a billion possible lines. This will be called algebra. This is algebra. When you do this, you represent numbers which is on this geometry line as symbols, generic symbols, okay? Then you're doing algebra. So algebra is nothing but arithmetic in symbol with symbols. That's what algebra is. So if arithmetic came from geometry, then algebra automatically came from geometry.
Correct.
So is there anything else? All is geometry. again, it's out there for anybody to take exceptions to, but that's it right there. As long as this is algebra and this is arithmetic, then arithmetic came from this number line here, which is geometry, and algebra, which came out of arithmetic, comes from geometry as well. Case closed. Okay? So that's how we say geometry is indeed the real math, which came into existence as a result of a glorification, a building of edifice by the ancient Africans to glorify the Almighty God for the gift of chemistry. Okay? All right. So how do you know this to be true? Well, you know this to be true on the basis, on the simple basis that when you were in high school studying geometry, what was the most popular shape that you dealt with? Yes?
Pyramid.
Yes, the pyramid or a triangle, which is basically a section of a pyramid. This is indeed a pyramid. Okay, you call it a triangle, but it's a section of a pyramid. Okay, triangle. That's the most popular. So it is not accidental that the triangle is a section of a pyramid. And the people that built the pyramid, the ancient Africans, definitely didn't jump into building of the pyramid in a rush. They did not rush into doing that. They studied it. They studied the science behind it, because the pyramid is considered the most precise structure in the entire history of the universe, or certainly this earth that we know, okay? The most precise, okay? Most precise structure ever built, okay? Ever built, okay? And of course, you know, it's so precise and nothing in New York or any of the big cities can match the precision of pyramids. And one of such precision is, for example, having a line or a section of a pyramid that will be 90 degrees. How you could build stuff like that, that's a challenge. To put this wall up to be 90 degrees takes a challenge, okay? But with a geometry science fully developed, you can do that, because if you have this side, okay, you want this to be perpendicular or 90 degrees, right? All right. And this is 20,000 years ago we're talking about. Okay. If you made this side 4 and that side 3 units, okay, and that side 5, this is exactly 90 degrees. And that's the kind of precision that you find in a pyramid. This will be 90 degrees. If this is 4, and this is 5, and this is 3, this will be 90 degrees. That's right. So you can see this is not approximation. You know, as long as you can have those units together, you will get a 90 degrees, column. Okay? So, and this is typically the kind of precision that overwhelms anybody that cares to check the pyramid out. That is meant. One of the guys that witnessed that and was touched by it was an English author called Graham Hancock. Hancock. Okay? It's an English author who went to examine the pyramid. And what he saw by way of precision was so overwhelming to him that he concluded that the pyramid couldn't possibly have been built by human beings. He believed that the pyramids were built by the gods. So the book that he wrote about that experience was called The Fingerprints of the Gods. Fingerprints of the Gods. Referring to the ancient Africans as the gods, because we know the ancient Africans built that structure, okay? But that's how he was taught, the fingerprints of the gods, okay? So that's the kind of precision that does not come out of some kind of a slapdash job, okay? It has something that has been studied and fully tested and so on. So it's like building a rocket, okay? You build a rocket to go to the moon, you don't do that overnight. Rocketry, or what you call rocket science, was, you had to come before building the rocket. The same way that geometry came, as a result of building the pyramid. That's the situation. Okay? So again, so now we know that ancient Africans were used by God Almighty to develop these two subjects called chemistry and geometry. And of course, very quickly as they were being developed, people began to learn from them, okay? For example, Pythagoras was an Egyptian citizen. He was born in Egypt, okay? He was born there, and he's classified among the 3 or 4 greatest mathematicians of all time. Primarily because of this thing here, okay? The 4-5-3 triangle, which obeys the so-called Pythagoras theorem, okay? Has to have existed before Pythagoras. Because not only did the people know it 20,000 years ago, and Pythagoras was way before, after that, okay? Not only did they knew that theorem, but they actually practicalize it. They use it in the construction. They use what is now known as Pythagoras theorem way before Pythagoras ever existed.
So, don't let me...
Certainly. Okay?
Yes.
All right. So therefore, so again, that's the science of geometry. All right. So now we move now to Gargot. What is Gargot? Okay? Well, God Almighty's grand unified theorem is Gargot. Okay? Okay? Well, first of all, before we get to Gargot, the problem that Gargot solved in a modern day language, okay, is called the problem of the unified field theory, okay, but this is OFAPIT, Institute of Technology. Okay? Home of Gargot. Okay? And everybody in the world needs to support it. Okay, GeoCities, geocities.com, I/IGA LA1 as the number 1. Okay? All right? And of course, the telephone number is 631-242-3069. Okay? Now, visit the website and you can get more truth. Okay? Now, Gargot solved the problem of the unified field theory. Solved unified field theory. Okay? That's the modern definition of the origin of the universe. Okay? All right. So, if the problem is the origin of the finding out the origin of the universe and how to understand the universe, then what's the word field doing there? What does that have to do with the field? Well, in actuality, it is called the unified force. Okay? It's getting crumb here. Force field. Okay? I'm going to force. Okay? unified force field theory. So why should we be considering a force field when all we want to do is understand the universe? Well, that relationship comes out in the following sense. I'm going to ask you a question. When you look around you since you came into existence, what have you observed to be the most fundamental thing about the universe? Movement, that's correct. Movement. Okay? Or motion. Okay? It would seem that everything in the universe moves. Okay? So therefore, if that is the case, then for a motion to occur, there must be a force behind it. Force causes motion. Motion. So if you want to understand the universe, either you look at motion or the force behind it. So if that is the case, then you want to look at the different kinds of forces that will provide motion. And in the modern study of the unified field theory, 4 forces, different kind of forces, have been identified. Number 1 is the gravity. And when we say motion, okay? When we say motion is a fundamental thing about the universe, well, we're standing here right now, okay? And it will seem as if we're static. We're not moving. But even as we appear static, we are moving. Why? Because the Mother Earth is moving. It's moving. It has, as a matter of fact, 2 different motions. Okay? You have a focus here of this ellipse. Okay? This is an elliptical path. Mother Earth is moving, along this. And then in addition, it is also rotating, okay, about its own axis. Okay, it's rotating like that, and so on. I want this to be clear. Okay, it's rotating about its axis. Okay, and then also moving around the sun. So that's 2 motion. In other words, here, Mother Earth is doing like this about its own axis, and we're all moving along with it. This is one reason why you need to pay attention to Gaga, because you don't have a choice in that motion. Mother Earth is so much under bigger force influence that you can't stop that. That rotation about its axis is where we get night and day. You've never been able to stop night and day from occurring. Nobody has. So, and we just move along with it. Okay? So that's one kind of motion. The other motion that Mother Earth is about is along this ellipse here, which, from where we get the seasons, winter, summer, autumn and the spring and all that, okay? That's where we get that from this motion around the sun. So we know that there's motion. And everything, on Earth, therefore, is moving. Everything in the solar system is moving. So there is no spot that has no motion. Absolutely none. So that's the basis on which we say that you know, if we want to understand the universe, we better understand that motion. That's where we're going to get an insight to the universe. And if either we study the motion directly or we study the force behind it. That's how the the problem became known as finding a unified force field theory. But first, you got to know the various forms of the force fields that exist. One of them is the gravity. Gravity is one of them, which is this one here. The one under which the Earth, Mother Earth, moves, okay? The Earth, okay, is called gravity because the sun is responsible for that motion over here and the spin as well, okay? The sun attracts it and keeps it on that trajectories. So gravity is one kind of force field that will cause motion like the motion of the planet, okay? The other one is charges, a property of a unit in the universe. If they have what they call a plus charge and another plus charge like electrons and protons and so on, so we talked about before, okay? If you have like charges, they will repel, okay? This will lead to repulsion. Repulsion, okay? And repulsion may be just something to describe the activity, but repulsion is motion. In other words, they'll be moving in this direction and moving in that direction. That's what repulsion is. Okay? If on the other hand there's a negative here, then there is an attraction, okay, between these two. Okay? Okay? They will tend to come together. Either way, these are motions. Okay? Attraction. Okay? Both of them are motion. And since we said that for a motion to occur, there has to be a force field, this kind of force field that comes from charges, okay, interaction between charges, is called electromagnetic. Electromagnetic. Electromagnetic.
So those magnets that we play with sometimes
yes.
are actually showing us.
Oh yeah, that's motion.
That's the actually
that's motion.
Gravitational.
That's
exactly what you're talking about.
Yes, that's a force field. Okay, gravity force field. Okay, and electromagnetic force field. Okay. Okay, and then the other one is related to what they came out of the atom. Let's take the lithium atom. Okay? It has a proton, actually 3 protons. Okay? And a neutron and a neutron and a neutron. Okay? So of course we have that, and we have that, and we have that. Okay? Electron that are. Okay? Now, this is the core here. We said that like charges would repel. So how is it that we're able to have 3 protons very close, you know, together in the nucleus of the lithium atom? How is that? If like charges repel, then the nucleus of the lithium atom and the other elements outside hydrogen, helium and all that should be unstable, to say the least. Certainly should be completely unstable if this is the case, because this will be pushing this and this will be pushing that, and it should be exploding actually. But that's not what happened. It is stable. How come? That is possible because there's another kind of force field that glues them together, keeps them together, and that is called a strong force field. Strong force field. So a strong force field would cause motion, or in this case, prevent motion. That means it's stopping motion. In other words, it has to move in the opposite direction to keep them from moving in the position you expect them to move in the first place. The repulsion should be pushing this apart. So the strong force field is keeping them together. So it's moving them the opposite directions. So that's called the strong force field. Okay? At the time of Albert Einstein, there were only two of this, but we'll get back to that. Okay, there were only two that were known in the modern science, except that the ancestors, I mean, the ancient Africans knew about the strong force field. Of course, for them to be able to make the pumping of the hydrogen units to make gold, they had to know about the strong force field, because you have to be able to overcome that, okay? As you pump in more hydrogen units in here, okay? You know, the positive protons are going to repel the ones that are coming. As a matter of fact, that is the central problem for the cold fusion, which Gargot has found a solution for. The world is looking for cold fusion. Gargot has a solution to that.
Expand on cold fusion.
Well, you know, we'll get, yeah, well, if cold fusion is basically, the end result of cold fusion is like using a cup of water to run entire New York City. And it's recyclable. Yeah, just so that's how great it is. But Gargot has a solution to that, okay? So, which is why you need to support the Fire Pit Institute technology, because unless we have funding, we can't put that into hardware. We have a solution to the cold fusion, okay? So again, so that's strong force field, okay? Another one, again, this, therefore, strong force field comes from the nucleus, and you can see how that produces motion. This produces motion, as you saw before. This is producing motion, and that we've proven how that produces motion by forcing the like charges to come together, okay, moving them in the opposite direction, okay? Now, the fourth one is, you know, in the nucleus, a proton could undergo, okay? A proton could undergo a transformation, okay? When conditions arise, proton, which is a positive, changes to a neutron, okay? See, they're all there together. So neutron plus a beta radiation, okay? And a weird entity called antineutrino, okay? This is called antineutrino, okay? And this, of course, is beta radiation. Beta radiation. Okay? Beta radiation. Okay, and this here is called the antineutrino. Now what happens is, proton is known to have approximately the same mass as the neutron. Okay? And a proton has the same charge in a positive charge, which is also balanced by the beta radiation. Beta has a positive charge. Electron that has a positive charge, that's what the beta is. Okay? So the charges are balanced. We have a positive here and positive. They're balanced on the left-hand side. The mass from the left-hand side is also balanced by the mass on the left-hand side, you know, in terms of the neutron. Neutron balances the proton. So that leaves these two what they call massless. Okay? Massless. But massless simply means very small masses, not totally zero. Zero means that it doesn't exist, okay? But it's massless in approximately, because in comparison with these others, it is practically zero, but it's not totally zero. It's very, very significant, okay? So what happens is then that for particularly, and of course, antineutrino has no charge because there's no charge on it. So here you have a unit that has zero charge and zero mass. Okay? So First of all, this combination is deadly. This is the basic origin of most of the cancers, where you have antineutrino and beta radiation. Okay? But what is more serious is the fact that antineutrino is not detectable by ordinary means. Simply because it has no mass and no charge. So how are you going to know its presence? So that creates a problem. But the fact that it's elusive, the fact that in reality nothing stops it, because if you have no mass you can pass through anything. And if you have no charge, the charge cannot deter you either. So it does not experience any or much resistance wherever it goes. Or, put another way, if it experiences resistance, the resistance is very weak. It can only experience a weak interaction or weak opposition on its track. Lead will normally provide protection with some of the radiations like the kind that come out of the strong force field, okay? But lead cannot stop neutrino. Neutrino can pass through lead. Okay? And because lead and other materials only give neutrino a weak resistance, this force field here, because that's motion, neutrino is moving as a result of this here. Okay? So that motion it comes out of a force field called the weak force field. Weak force field. Simply because neutrino cannot be stopped, or you can only impede it in a weak manner. You can't really give it any strong opposition on its track, okay? So this therefore becomes the four force fields that are being studied in the modern day physics, if you will, okay? Now, but there's a common denominator as such, in the sense that all of them, produce what we said before, motion. Okay? The end result of this gravity, electromagnetic, strong, and the weak force, is motion. So, scientists, thought that they all should have a common origin. And if we can find this common origin, it will give us an insight to the universe. So Albert Einstein spent his time, he was searching for what Gargot solved, the solution to that problem, when he came out with E is equal to mc squared, which is something he's very well known for, okay? He wanted to unify gravity and electromagnetic force field on this base that they all produce motion, therefore they should have the same grandparents, okay? And so, but in the process, he was able to develop a very beautiful theory for gravity, as a force field, okay? And of course, Maxwell had already developed an electromagnetic theory that was quite beautiful. So he wanted to take what he developed for gravity and unify it with electromagnetic, so that he could say, okay, well, we have these two forces, and they come from the same origin, and from there go to understand the universe, okay? Well, of course, from 1921, or actually 1916, to 1955, when he passed on, he spent his time, looking for ways to unify these two forces with only a partial success. He didn't succeed in unifying them. So that left the problem, given his stature and so on and so forth, as a very popular, very important, very significant problem to tackle, because it is believed that if you're able to solve that, then you've done something that Albert Einstein, was unable to do. Okay, so that makes the problem very popular. So everybody jumped on the bandwagon trying to find it. Okay, And what Gargot has done, okay, in terms of being a unified force field theory, actually it's a theorem because we proved it mathematically, but also in addition to explaining chemistry and its chemetic origins and so on and so forth, and the mystery itself that surrounds the name itself, Gargot was able to unify all these four forces as well as all the forces that have not been known yet. Because the reality is that Albert Einstein, even if he had unified the gravity and electromagnetic, with the coming or the knowledge of strong and the weak, his accomplishment would have still been incomplete because people would have still been trying to find a way to unify strong and the weak along with those other three. So, but what Gargot did was to unify all four plus others that have not been thought of yet. Now, how did Gargot do that? Well, Gargot examines, of course, it's a 35-year-old journey, okay, that took me from a city called Ida, that's Idaho without an O, okay, Ida, okay, in the Gala Kingdom of Nigeria, okay, a kingdom that originated from Kemet, okay, as a result of the invasion of Kemet by the Arabs in 641 AD. 641 AD, the Africans in Kemet left, okay, and they were driven out of Egypt, if you will, okay, and those that came to Nigeria settled in a place now called the Gala Kingdom, okay. So 641 AD was when Africans moved from Kemet to what is today called Nigeria, the center part of Nigeria, and established a kingdom called the Gala Kingdom. Okay? Now that's where I was born, in Ida, which is the headquarters of Ida, of the Gala Kingdom.
And your ancestors told you that?
Oh yeah, no, that's part of the education that you learn in terms of, well, how did you get here? Of course, Oxford University studies have indicated that the Gala people, okay, and there are Galas all over the world, by the way. 75% of Ethiopian population call themselves Gala people. Angola is the land of the Galas. Sierra Leone has, Gitchis or Gala people as well. Ghana, Nigeria, of course, we mentioned. The language in the Congo is called Lingala. Okay, Lingala is the main language in the Congo. That's the Gala. And so on and so on. Even Madagascar has a significant population of people called Gala people. And I would be surprised if Australia has some as well. People we call Aborigines, could be part Gala people and so on and so forth. And of course, the South Carolina has the people you call the Galas and the Gitchis. The Gala people is the same people. So it's a name that people living in Egypt call themselves and settled all over the place. So that's the Gala Kingdom. And there's a very serious tie between the Gala Kingdom and Kemet in the present day setting, in the sense that embalming that Egypt has been known for is still practiced in the Gala Kingdom of Nigeria today, especially for the kings. The Ata, which is also a word for Ptah, okay, Ptah, okay, it's called Ata, or ATA, okay, in Nigeria is the title of the king. And Ptah is on the hill, the top of the hill, which Ata is like a father, which also the king, or which is the center, the hill of the people, and so on and so forth. So there's this tie, and so on and so forth. There's so much ties, and in fact, we understand that in some parts of Egypt, Gala language is still spoken. Okay? Yes. So that's a very strong tie there. But anyway, that's where I grew up learning all this stuff here. And of course, having known about the origin of chemistry, the mystery of the ancient Africans, as well as the fact that they developed, by the inspiration of the Almighty God, the subject called mathematics in a form called geometry, then I kind of sense that I have work to do. And as a result, when I would go to, I went to, after the education, what they will call informal education, where this was picked up, I would go to an elementary school called St. Boniface's, okay, in Ida, Boniface's, okay, elementary school, Ida, okay, and then from there went on to St. Augustine, okay, high school in a city called Kaba, okay, and while I was in St. Boniface's, there were some experiences that I don't know if I have time to, but I'll go quickly, in terms of math experiences, okay? In the class, or rather the school, St. Boniface's, the attendance was a big deal in terms of, getting a promotion. So in my 5th grade, it was a practice there where the best math students would be actually, brought together to add the attendance for each student to determine if they're promotable to the next class. Mm-hmm. So in this case, I think about 5 of us were selected. I happened to be one of the group. A group. I was considered one of the best, okay, in math, okay. However, the teacher didn't really like me that much because I had some other features that the teacher didn't like too much. So anyway, so he grudgingly selected me. On the basis of my grade, I was fine. But the other 4 were giving a form of calculators to add the numbers. And I was not given. I remember vividly sitting on the desk. They were sitting on a chair with their whatever calculator they had on the table. I was sitting on the table with my hands folded. So, and what they would do is to run the numbers of the attendance for the week, okay? And what they would do is, they'll take roll call in the morning, midday, and then closing, and so on and so forth. So that brings to a total for a week, okay? 3 times 5, which is 15. A perfect score would be 15, okay? And they will run this for all the weeks of the school year, okay? To determine if you were 75% present, okay? So I didn't have a calculator. When he ran the first set for the first student, I gave the answer before the people with the calculators. And of course, the teacher basically ignored me and said, yeah, Oyibo, shut up, let me really hear the real answers, okay? And when the real answers came, it was exactly what I had given to him. And of course, he ignored that. So let's move on. Lucky coincidence, he said. So the second time he ran that again, I gave the correct answer again. And of course, it took the calculator people some time to, after I had given the answer. I said, gee, you noisy, please let me hear the right answer. The right answer again turned out to be what I gave. The third time when I gave the correct answer again, he stopped the whole operation and said, listen, Oyibo, I know you are a noisemaker and everything, but I didn't realize that you were also possessed. Could you possibly explain how, without a pen or pencil or a calculator, you could give the answers to these many numbers that I'm reading out, okay, before the calculator? And I said, okay. I thought, okay, I'll tell you. My hands still folded. I said, listen, as you were running the numbers, I made a mental decision that the number 15, 14, 13, 15 again, and so on and so on, I wasn't adding those. Those are big numbers. What I would add was the number of times the people were absent, which is a much smaller number. So when you run 15, I will record nothing. You run 14, that's 1, okay? 1 absentee, okay? And so when you run the first guy, there was only 3 times he was absent. So the number of times or weeks they run in a school year is a fixed number, say 40 or something like that. So 40 times 15 is a known number. I'll subtract 3 from that 40 times 15, you know, and give you the answer. That's what I was doing. Okay? So yeah. And he looked at it. That's, yeah, most of the 15, 14, all those that they're crunching, those are big numbers. But the 1, 2, 1, 2, 0, 1, 2, 0, that's nothing. So from that point, most of them started doing it that way. So anyway, so it settled the issue. Then, of course, move on to Augustine, St. Augustine cover, where, again, I was consistent with my noise making. The noise making was really a protection kind of mechanism for me. I could talk. Okay, actually, it wasn't really noise. It's really talking when you're not supposed to be talking, okay? I'll be discussing things, you know, the history and everything, and math, interest in math. Anyway, I was doing that in the St. Augustine, and what happened was I would be punished, and my punishment was to add number from 1 plus 2 plus 3 plus, okay, to a number, an unknown number ending called n, okay? And the first time I believe the number n was about 900 and something, 970 or something like 900, okay? Or, you know, 930 or something like that, okay? So you add in 1, and you have to do this without a calculator, okay? 900 and something. So I did that and I sweated, okay? The next week, this number rose to something like 3,000 something, okay? Oh boy, it was getting really unbearable, and somehow I couldn't really stop this noise, okay? So finally, the third time, it was in the 500s, okay? Okay? Actually, 900 was, you know, closer to 1,000 actually. But anyway, by the time the third week of the punishment, I found a formula to make that addition possible. And if Sn, okay, was the sum to n, okay, I found that if I divide the last number by 2 and multiply it by n plus 1, I will get the answer exactly. Okay? Later on, I will see that as a geometry, as a matter of fact, a geometric kind of situation, because this is length times breadth, which is geometry, a rectangle. Okay? So anyway, so the teacher was shocked, because not only did I produce this formula and use it in solving the third punishment, but I could prove it mathematically. Yes, I proved it mathematically. Okay? And if you push me right now, you know, I'm going to have to scratch my head a little bit. I can give you the proof. But anyway, so I took the proof to him, and I gave it. He said, well, he said, Oyibo, do you realize what you've done? And I said, well, I found a shortcut to your punishment. And of course, he cracked up and said, well, beyond that. And I said, no. He says, does the name Gauss mean anything to you? G-A-U-S-S. And I said, no. And he said, well, there are 3 most famous names in mathematics. Gauss, Euler, in modern times, that is. They will add Archimedes, you know, if you consider what they call antiquity, okay? But, and Newton, okay? The most famous mathematicians. And he told me that Gauss came into that fame by devising the same formula. And of course, I was excited, and of course, you know, and I asked him for a book on Gauss, you know, and I eventually found out that what he said was correct. And so I was very excited and moved on to learn more about Gauss, Newton, Euler, and Einstein, you know, and all the others. Then found out that Einstein had developed relativity theory and was searching for this way to unify the gravity and electromagnetic force fields. So I took interest in that, of course, proceeded, and after 35 years, finally the solution evolved. Okay? I discovered in the process that relativity was an exercise in geometry. Of course, if it is math, it's got to be geometry. But I particularly noted that. And Albert Einstein indeed gave a hint. Okay, even though he didn't solve the problem, he gave a hint. And the hint, which was very helpful to me, was that, yes, even though he was unable to solve it, in his guts he believed that the unification will have to lie in geometry. So, in effect, it helped me narrow my focus. Okay, knowing, of course, that relativity was in an exercise in geometry. I studied that and all that, and what we call Geiger today is as a result of a geometric search, for the way to unify force fields. Okay? What Geiger came up with is the God Almighty's grand unified truth or theorem says that the universe is a geometric space. Okay? Geiger says universe is a geometric space. Geometric space. That is filled up with motions, as we just said before. Just picture a universe, a geometric space, whether it is limitless or unlimitless, that's immaterial. Just space. That is filled up with motion. It's all in continuous motion. That allows Geiger to conclude that, therefore, because the universe, as we said before, is motion, it's also filled up with a force field. And that in this force field, therefore, matter or solids and things that you can touch and feel are simply concentrations of those force fields. Concentrations. Matter are concentrations. Concentration of field, of the force field. Okay? So what that says, in effect, is basically that is total. The entire universe is motion, therefore is just pictured as a force field. And that essence of God is that totality. That's what you call God. And so, by taking as part a space-time point in that geometry, the force that comes into that point and the part that is absorbed, either for creating these concentrations or whatever, and the part that goes out, there is a conservation, meaning that there may be transformation and so on and so forth, but it does not disappear. That's what conservation is, which is in another way of saying that Gij, comma j is equal to 0. This is Geiger, and this is the theory of everything. Okay? This could be interpreted